I got a request from someone who loves fluorine and organofluoro compounds, so let's have a look at these substituted amphetamines, one of which has a fluorine atom. Shilgin's notes on these compounds show that the simplest one wasn't that impressive. His notes don't seem to suggest anything amazing. Adding a bromine atom increased the effects a little bit. He seems ambivalent at first, but ultimately seems to consider it a positive modification. And as for the fluorinated compound itself, it seems to have had some interesting physiological effects, judging from his write-up. Anyway, let's have a look at the overview of the synthesis with the molecules of interest highlighted in blue. They all lead on to one another, with the fluorine compound as the ultimate product. The first step, dimethoxybenzaldehyde is condensed with nitroethane in a fairly simple condensation. Ammonium acetate was also used, and elimination of a molecule of water gives a beta-nitrostyrene, which Shilgin reduced with lithium aluminium hydride. This is a fairly simple mechanism which has a lot of steps, but eventually it reduces the compound to this amine. Molecular bromine in glacial acetic acid was used to brominate the ring at this position, the electrons pushing from the methoxy group and the loss of a proton restoring aromaticity. It's probably worthwhile to consider the regiospecificity of this reaction. The methoxy and alkyl groups are both directing towards that position, whereas only the single methoxy group is directing towards the alternative position. The next step involved protection of the amine group using this slightly weird-looking silicon-containing molecule. A pair of SN2 reactions displace chloride ions and protect the nitrogen within this 5-membered ring. Once that protecting group's been added, the molecule is tolerant to a lithium-halogen exchange using tert-butyl lithium, which substitutes a lithium in for the bromine, forms a reactive carbanion which then alkylates by reacting with a molecule of ethylene oxide. And once that modification is done, Shilgin swapped out the protecting group for this trifluoroacetate, presumably because the former wasn't tolerant to the conditions he used in the fluorination step, which uses diethylaminosulfur trifluoride, more easily handleable than SF4 because it's a liquid and less prone to contamination, according to Wikipedia. Anyway, the alcohol attacks the sulfur and displaces a fluoride ion, and the displaced fluoride comes back and pushes off the oxygen-sulfur species. The only thing left is to remove that protecting group with a reaction that's not very interesting, and the final product is this fluorinated amphetamine derivative.